All right, guys, so in this lesson, we're going to take a look at some elimination questions that might be a little bit more difficult, where you have to do some work in order to get to a place where you can eliminate one of your variables. So in some cases, you may have to multiply one or both of the equations by a constant. Okay, what is a constant? All a constant is just a number. So that one variable has opposite coefficients or numbers. Okay, so let's take a look at what this means. Let's take a look at example one. So our goal here is we need to eliminate one of our variables. We either want to eliminate the x's or we want to eliminate the y's. So before we eliminate, the first thing we got to make sure is we got to try to make sure that one of these variables has either the same or the opposite coefficients. So let's compare what we have right now. We have a 3 in front of this x, and we have a -1 in front of the second x. Okay, those are neither the same nor the opposite, so it can't be that one yet. Then if we look at the second pair, the y's, this guy has a 2y and this guy has a 1y. Okay, those are completely different numbers. So the issue we're having right now is that we don't have the same or the opposite coefficients yet for either pair of variables. But what we can do is we can introduce a constant. We can multiply an entire equation by a number in order to get to opposite coefficients. Okay, so watch what I'm going to do here. Let's say I make it up in my mind that I want to eliminate the x's. Okay, I want to change this bottom equation so that I have opposite coefficients between both of my x terms. Okay, so I ask myself, okay, there's a 3 up here. How do I change this -1 to make it a -3? What can I multiply -1 by to make it -3? What I'm going to do is I'm going to multiply this entire bottom equation by plain old +3. Okay, so when I rewrite this, this 3 is going to distribute to every single term. I'll have -x times 3, that should be -3x, plus 3 times y, that's 3y, equals -2 times +3, that should give us -6. Okay, so what I've done is I've changed this -1x into a -3x by multiplying the entire equation by 3. And when I compare it to the original top equation, the guy up here, 3x plus 2y is equal to 6, what I notice now is now that I have actually opposite coefficients. So I'm able to eliminate my x's now. And whenever I have opposite coefficients, I'm going to make this one big addition question. My variables are lined up. So let's add the x's together. If I have -3x and I add 3x's, that basically means the x's cancel out and I'm left with 0. Okay, that's exactly what I want. I want the x's to eliminate. Then I jump to the y's. I have 3y plus 2y. That should give me +5y is equal to -6 plus 6. -6 plus 6 is equal to 0. Okay, this 0 doesn't really matter, so what I'm left with is 5y is equal to 0. And if I want to solve for y, I divide both sides by 5, and I should get y is equal to 0. Okay, so once I get to this point, I'm basically at the exact same place I would be with any other type of elimination question. I now have to solve for x. So I pick whatever equation I like a little bit better. Do you like the first one or the second one better? I like the first one a little bit better, so let's rewrite it. Wherever I see a y, this time I'm going to plug in a 0. So I'm rewriting the first equation. I still got a 3, I still got an x, I still got a +2, but instead of writing y, I'm going to write 0. 2 times 0 is equal to 6. What's nice here is 2 times 0 is just equal to 0. All I'm left with is 3x is equal to 6. And I divide both sides by 3, and I should get x equals 2. If I want to write this as an ordered pair, I would write this as 2, comma, 0. All right, let's do another example. This one's a little bit tougher though. So once again, we're trying to solve this using elimination. We're trying to eliminate one of the variables. And remember, if we're trying to eliminate one of the variables, we want a pair of variables to have either the same or the opposite coefficients. So I look at both my pairs right now and I ask myself, do either of those have either the same or the opposite coefficients? I'm looking at 2 and -3. Okay, no, those are definitely not the same or the opposite. And I'm looking at 5 and -4. Okay, those are two completely different numbers. So I don't have either of these right now. So what I have to do now is I have to multiply either one or both of these equations by something in order to get the same or the opposite coefficients. Okay, but the issue I'm running into right now is that it's not super easy to multiply either of these equations by something in order to get the same or opposite coefficients. If I'm looking at the x's, I ask myself, okay, can I multiply 2 by something in order to turn it into a 3 easily? Okay, not really with multiplication. It would have to be a fraction. We don't really want to deal with fractions if we don't want to. And the same with the -4 and the 5. I can't multiply 4 by something in order to change it to a 5 without using a fraction, so I want to try to avoid that. Okay, but there's nothing saying that I can't multiply both equations by a constant in order to get the same or the opposite coefficients. Okay, so watch what I do here. Let's say I make up in my mind that I want to eliminate x. X is my favorite variable to eliminate. What I'm going to think in my head is I'm going to think, okay, what is the least common multiple between 2 and 3, or 2 and -3? And I know the least common multiple between these two numbers would be 6, between 2 and 3. Okay, so what I'm going to try to do is I'm going to try to change this +2 into a +6. And how do I do that? I'd have to multiply that entire top equation by 3. So watch what happens here. Why am I choosing 6? And I'll show you in a second. This 3 is going to distribute to every single term. I'll have 2x times 3, which is 6x. 5 times 3, which is plus 15y. And then I'll have 26 times 3, kind of a big number, 26 times 3, and I'll get 78. Okay, so I multiplied my entire top equation by 3 in order to change that 2x into a 6x. Now, I do the same thing for my bottom equation. I want to change this -3 into a -6. How do I do that? I have to multiply that entire bottom equation by plain old 2 and distribute across. So watch what happens here. I'll have 2 times -3x, which would give me -6x, 2 times -4y, which would give me -8y, and then 2 times -25, which will give me -50. Okay. So what I was able to do by multiplying both my top and my bottom equation by a constant, I was able to change this 2 and -3 to 6 and -6. Now what I have right now is I have opposite coefficients in front of my x's. So now I can make this an elimination question. I can eliminate my x terms by making this one big addition question. So if I have 6x, and I add -6x, I'm left with 0. And that's exactly what I want. My x's are gone. They're eliminated. I'll have 15y plus -8y, and that should be plain old +7y. And then I'll have 78 plus -50. Basically the same thing as 78 minus 50. And that should give you 28. So what I have right now is I have 7y is equal to 28, and I divide both sides by 7, and I should get y is equal to 4. Okay, a lot of work to get that first variable isolated, but once I have this, the rest is pretty easy. So I did a bunch of work with these ugly equations and I tried to scale them up. But when I solve for x, I want to jump back to those original equations that I first started with. It's either the first or the second equation. Which one do you like better? I think I like this first equation a little bit better, so I'm going to use this one to solve for x. I'm still going to have 2x. I'm still going to have plus 5, but instead of saying y, I'm going to plug in 4 for y is equal to 26. 2x plus 20 is equal to 26. Subtract 20 from both sides. 2x equals 6. Divide both sides by 2. And I should get x equals 3 as my answer. And I would write this as an ordered pair. The place where these two lines cross would be the coordinates 3, comma, -4.